This video is a comprehensive overview of the basic options available in the DAMS Antenna Measurement Studio and instructions for making a basic antenna measurement. To begin with, we would configure the positioner by first verifying that the picture matches the positioner in use. If it doesn't match, open the positioner settings and select the appropriate model. In this case, we are using the full spherical mount without the FSM conical elevation. This window also contains more advanced settings such as toggling move and measure, or measure but not move, as well as adjusting the gear ratios, the COM ports, the horizontal and vertical speed, plus acceleration settings, and more. Once the settings are configured to your liking, close the window and click No Restart on the pop-up warning. Next, select the appropriate source from the drop-down menu. The default is the VNA emulator. Each source has an associated settings menu. In the VNA emulator, the settings menu is an antenna design reference library. For each antenna in the library, the design details are displayed. For each type, such as an arbitrary beam, we see the design details for that antenna once it is selected. Such details include the beam width and the arbitrary direction. The standard and most widely used antenna is the ideal quarter wave dipole, which can be orientated horizontally or vertically. The frequency range for the VNA emulator is input manually. For any other test equipment, the frequency range is actually derived from the equipment itself. In this case, we're going to scan from 1 GHz to 8 GHz with 101 frequency points. Frequency lists can also be input. The system can be calibrated scalar, or if the VNA is vector calibrated, then the scalar calibration becomes redundant. In the calibration system, we have two steps. First, we have the straight-through calibration from port 2 of whatever is being used through the top of the platform and back into the VNA. This will level the system and can be even used to level the system with a path and reference horn. If a post amplifier is used, then it's required for a pad to be inserted which is large enough to prevent saturation of the amplifier. The pad value can be entered and the system is calibrated. Power meters with power heads can also be calibrated. Calibration files can be loaded or saved. Upon exiting, a prompt will ask you if you'd like to save, apply, or discard the calibration. In the emulator, the measurement that results is the gain of the selected antenna. When measurements are made in an actual link, the gain is the total link gain. From here, we would then go on to configuring the extents. The default extents for the DAMS are 0 to 360 degrees azimuth with 10-degree steps, and -90 to +90 degrees elevation in steps of 10 degrees. In the Configure Extents dialog box, we can change these parameters with the slider bars. When the sliders are moved, the radar preview window automatically updates, illustrating exactly where the measurements will occur. There is also an option for beam cuts, which sets the azimuth settings to 0 to 180 degrees. In this case, we are just going to use 0 to 360 degrees azimuth in 5-degree steps. If we wish to move the platform without any interaction with the test equipment, we can utilize the jog settings. If we tell it to jog left on the azimuth settings 5 degrees, we can then see the position changes to -5 degrees. This can be useful when you're centering your antenna. Also, at any point, we can reset the positioner back to 0. Now that we've covered configuring the movement settings, we'll now look at monitoring the plots. The amplitude monitoring plot is a self-scaling dB plot which enables real-time observations. If we wish to change the frequency of the monitor plot, then we click Monitor Plot Options, and this will allow us to change the frequency slider to whatever our desired frequency is. Other options are also available, such as real-time gain plotting. In order to use the real-time gain, you must enter the path into the reference horn. If we are measuring noisy data, then we have the option of averaging. The default averaging setting is set to 1, though any number of averages can be entered. 2 averages doubles the time a measurement takes. We also have the option of using all data and throwing out the min-max. This can be advantageous when interference is present. The display setting for the polar monitor plot can be changed as well. Traditionally, the 0-degree point on the polar plots is straight up. However, the default for the DAMS is 90 degrees. If you wish to change the polar plot orientation settings, you can do so in the display settings. We're now prepared to go ahead and emulate a measurement. It should be mentioned that emulating a measurement with a VNA antenna is also advantageous for generating a reference antenna. All of the measurements in the VNA emulator are from standard antenna handbooks. Now we're going to emulate an azimuth cut. As we do, we can see it's an ideal dipole from the emulator. The measurement took less than 10 seconds and we monitored the frequency at 1 GHz. The progress window shows us the progression of the scan, which can be helpful for longer, more complicated measurements which can take several hours to perform. In this case, the start frequency was 1 GHz and the end frequency was 8 GHz with 101 points. If we reset to initial position, the data will be erased and the platform will return to the start position. At that point, we're prepared to start another measurement. At this point, we can make an elevation cut or a complete scan. If we choose to do a complete scan, then we will do an as over L and monitor the progress on each of the dual progress windows. We can see the elevation progress window slowly progressing, while we can also see each individual sweep on the azimuth progress window. Now that we've completed the scan as L button is re-enabled. Now we will enter the data processing area. First, we will save the current data to register 1. We can now see that there are 71,000 measurement points. We can always view the as L extents of the measurement or make use of the register utilities. The register utility options include loading a single register from a previously saved file. You can also do a frequency merge, which will allow you to merge multiple files. Typically, this is a measurement with a low band, a mid band, and a high band reference horn. Registry data can be exported into a text file or as an Excel file. A previously saved calibration file can be applied to Reg 0 as well. Calibration files can be imported and registries can be cleared. In the event an error occurs in the advanced section, recovery will recall the data which was last saved, traversing the measurement to the advanced system. An emergency backup file is also always saved. And this concludes our overview of the basic measurement options for the DAMS Antenna Measurement Studio. If you have any questions or comments, please feel free to email us or give us a call. We thank you for watching and hope this video was informative and helpful.